Hi everyone. I'm going to start the practice sessions, I guess, for this summer. So for those of you who are new, basically this is the summer because people are not necessarily here. I'm going to start post problem sets more or less every week unless I'm away, and people can practice. And then at the end of each week, I'm going to show you my solutions and how I approach these problems. And then, of course, as always, whenever if you have any questions, you can always either ask me in person if you're around, or I can, of course, answer messages, whether you use email or Discord or whatever. So the first week, I guess I have four problems that I chose, and there's no real theme to it other than the fact that they are um, hopefully don't require too much knowledge. But anyway, what I want to do is to show you how I would approach these problems. All right, so let's get started. First one, eeny, meeny, miny, mo. There's some kind of nursery rhyme, and you choose people based on how many words you have in this rhyme, and you just keep choosing people, and so on. So I assume, so I'm not going to really go through the problem statement too much because I assume that you have read it. If not, please read. And let's just highlight what's going on. So if the phrase, the rhyme is four words, then you count four times and the fourth person is selected, right? So two teams are to be selected for a game. You alternate between the two teams until all the kids have been selected. Kids are standing in a circle. In each selection round, we start counting the kids clockwise around the circle, skipping the kids for every word in the rhyme until the last word. The kid matching the last word is chosen for the current team, and then the next round starts, etc. Can you tell, given a rhyme, a group of kids, can you tell which kids will be in each team? So, um, illustration of sample one. Sample one has this rhyme that only has three words, four people. So you start from the first one, Kelly, Lisa, and Alpha. Alpha is the third one. So that's the first one that you picked. Then you go three again. So you have one, two, and three. So Lisa is now the second team. And then you look at this one, and this one. Remember, we skip over people that you already chose. So now he's the second person on the other team, and so on. So first line of input contains a rhyme, consists of a list of words separated by spaces. That most 100 kids follow the names of one per line. Kids are given in clockwise order. First kids listed is the one that you start counting in the first round. All the names are upper and lowercase letters. No line is empty or longer than 100 characters. And then the output is output two teams, starting in one whose first member is chosen first. First for each team, output the number of kids on the team, followed by the names of the kids in the team in the same order as they were chosen. So basically, you have to simulate this. Um, we have to decide what we're going to use to store the input, the list of names, for example. We have to figure out how to store the list of names of the two groups, two teams. For the output, the list of two teams, it's probably easier just to use two vectors of names because you can just keep pushing back of the teams as you add more people. And then this one is a little bit trickier because um, I mean you could store it as an array or a vector, but you also have to say, well, what do you do when you remove a person in this group, right? Because you have to be a little bit careful. So anyway, let's get to it. So I'm gonna use Emacs because that's what I use, but you use whatever ID that you want. And let me make it a little bit bigger so you can see it clearly. And we start by, for competitive programming, I usually use this. For any other purpose, you probably should never use this, including bits slash stdc++.h basically grabs all the standard include files that you can possibly include. So it's not a good practice for anything else, but for competitive programming, this is reasonable to save you a bit of time. Okay, so we have main. What are we going to do? The first thing we're going to do is read the first line, which has the rhyme. Now, you can't just read this as a bunch of strings using the, you can't just do this. Like this, because this will only grab you one string, the first word. And even if you do it multiple times, you wouldn't know when the line ends. So what you actually have to do is to use getLine. Like this. Okay, so that will get the whole line. Now the question is, how do you break it up into the words? We actually don't care. Why do we not care? Because the words are not the important things. What is important is how many words there are. So one way that we can do this is to just count how many spaces there are. Because if there are 2 spaces, that means there's 3 words. Right? The number of words, it's always the number of space plus 1. So what you can do instead is to say, okay, what do I want to call this? Let's call it length of the rhyme. I'm going to count my string and count how many spaces there are and then add 1. So count is a C++ library function that allows you to count some kind of a container. In this case, a string is a container of characters, and you count how many occurrences of spaces there are, and whatever it is, I add 1, and that's the number of words in the rhyme. Okay, now we have the number of kids. So and then I'm going to have the number of kids, the name. So I'm going to use a vector string and call it, so let's call it num kids. Like this. And this will read in each of the names. So if you're not familiar with this type of for loop, it basically goes through everything. So this, first of all, create a vector of strings that have exactly the right number of elements. And then the for loop, in this way, this is called range-based for loop. It will loop over all the elements of the vector, and for each one, do something. And the fact that I used pass by reference means that if I read it into there, it will actually change the value of the elements in this vector. So now I've read everything. All right. So now, what are we going to do? So originally, I'm going to have an index of 0 because that's where I start. I also need 2 vector strings. That's called team1 and team2. In fact, I'm just going to do it like this. So I'm going to have 2 empty teams, 0 and 1. And the current team is 0. So this current team is going to switch between 0 and 1 every time. So it will assign to alternate teams. So what are we going to do now? So we're going to do this n times, num kids times, because every kid needs to be assigned like this. And now what am I going to do? I'm going to say for, okay, uh, so I'm going to skip this many times when I count. Okay. Actually, it's -1 because if there's, let me think here. So if if the length of the rhyme is 3, I need to move forward 2 steps, right? Because if I'm here and I need to count 3, I'm already on here already. This is the first one. So I need to go forward 2 steps. So that's why I do -1. Okay, always remember where, check whether you're doing the numbers that you're doing. Is it one too many, one too little? Okay, that's a very common mistake to make. So here, num skip is, so I need to skip that many. And so while num skip, it's bigger than 0, I have to keep going. So how am I going to keep going? Index, it's equals to index plus 1. But because this vector is circular, if I go over to the end, so if I'm at position 3, the last one, remember 0, 1, 2, 3, then I add one more, now I'm in index 4, and that's out of bounds, so I need to go back to 0, and the way I can do this is by taking the mod of the size of the array, or the vector, and now I need to remember that num skip, it's 1 less because I skipped 1. Now you might be wondering why I don't just write this as a for loop that goes num skip times, but I will get to that. Because now the thing is, at this point outside of the loop, I would be ending at exactly the place where I need to remove this person. So I'm gonna say team cur team dot push back the name of this, so to this kids index. Okay, so I just moved that person over. But the question is now, what do I do with this in the original list? Because in the original list, I need to make sure that from now on, I never touch that name again. And when I count, I skip over. So there are a number of ways you can deal with it. One way is you can actually physically remove that entry, okay, from the vector, or you can change the name of that entry to something else that you know for sure is not going to be valid, and then you skip over it when you count. So the way I'm going to do it this time is to just change the name to be the empty string. So for sure you cannot count it. And then over here, instead of always saying that num skip minus minus, I would say if kids index not equals to the empty string, then you can count that as a skip. Okay, so basically this makes sure that people that you have already taken, you will not count them again. And then finally, I need to switch the team, and this is how I can do this. It switches from 0 to 1. If your current team is 0, it becomes 1, and 1 becomes 0. And so this should put all the people in the right teams. And this loop on the outside makes sure that everybody is eventually assigned. The fact, so you might say, well, this seems to be a little bit inefficient. And it is, because you might have to go over people that you have already picked over and over again. But because there are only 100 kids at most, right? So that means that you're not, and the rhymes cannot be that long. Does it say? No input line is empty or longer than 100 characters. So the rhyme itself cannot be that long either, right? So it can only be at most, I guess, 50 words, because if there's at most 100 characters and there's spaces to separate words, you can only have at most 50 words, let's say. So even if you have to go over the same thing picked over and over again, it's not going to be that bad. Because the worst you can do is to go through the list 50 times. So 50 times 1,000 is not that bad for every kit that you picked. Anyhow, so now that we have picked everything, what we need to do is just produce the output. So for the team, the two teams, first we print team I.size. And then we print each of the team members. Okay, and that should be it. Now, I'm not saying this is the only way. You can certainly actually physically remove the items when you move them to the teams. You could use, for example, a list in C++ that it's better for arbitrary inserting and deleting things in the middle. But actually, because it's only 100 items at most, you could just use a vector and delete them in the middle. It's less efficient, but again, because it's so small, efficiency is not a huge deal. Okay, I'm not even going to try to compile this and make sure it works. I'm just going to submit and see what happens. Upload files. Let's hope that it actually compiles and works. Oh, what did I do? Oh, because I called it T. I didn't call it I. So that's, and this is wrong arrows. It should be 2 while I'm looking at it. Okay, so let's try again. Normally, you should probably compile it on your machine locally and try the sample input and output before you submit. You see, it doesn't even work for the sample input. So let's see. Okay, so maybe I should actually do something. Okay, so apparently I got this backwards even for the sample. So let's carefully think about what's happening. All right, so the first person I picked alpha. That's not a problem. And then once I pick this one, the question is, how do I pick Lisa next? So go 1, 2, 3. The problem is, after I pick alpha, I'm still sitting here. And so I start my counting here instead of starting my counting the next time. So what I need to do at this point is actually that I need to skip how many. I need to move forward before I can start counting, right? But if I move forward once, that could also be somebody that has already been picked. So what I need to do right here, after I switch, I need to move for my index forward until it is no longer an empty string. Otherwise, it won't work. So I would have to say, wow, kids index equals to this. I'm going to move it forward. Index equals to index plus 1, like this. So that's that was the problem. So maybe now I should actually, test my program and make sure it actually works before I submit it again. All right, so I'm going to compile my program. That's how I compile them. The -w all turns on all possible warnings that may be correct C++, but could be indicate that I might have a mistake, but no warnings, everything compiled cleanly. So now I will run like this, and that will run my program on the first input. And now I have an infinite loop, it seems like. All right, so let's see. It has an infinite loop because the very last step, when I chose the very last person, this loop will go forever. Okay, so because everybody by then, once I chose the last person, everybody will be blank, and so this loop will go forever. So what should I do? What should I do is I should actually move this loop at the beginning before I remove anybody. So that will fix it. So I only do this moving if, yeah, okay. And then here, BC1A. Okay, so where is the, here it is. So I want to show you that, I know that this is not intentional, but, this is also figuring out what you did wrong and try to debug it is also a very important skill. Okay, so here we are. Now, is this the best way? Perhaps not. You might actually want to just remove things. If you actually remove the entry so that the vector that you have of kids, it's always exactly the number of kids that are actually still in there, then you actually don't need to do this counting one by one. You can in fact just, if you need to skip 5 steps, you just add 5 to the index, and of course taking the mod, and that would allow you to jump directly. And perhaps that's more obviously right than counting and sometimes skipping and sometimes not skipping. Okay, but anyway, this is one way that you can do this. Okay, so next one, fast food prices. Fast food price. So you have some stickers that you can get, and you have sticker types, different types, and every time you get one sticker of each type, you can claim a prize. You can claim a prize multiple times if you have multiple stickers at the same type, but no prizes will require the same type of stickers. Um, there may be some stickers that cannot be used to claim a cash prize. Blah blah blah. How much cash can you claim? Okay, so input consists of many test cases. First line, a single integer that indicates number of cases to follow. Each case starts with a line containing two integers n and m. N is the number of different prizes. M is the number of different types of stickers. And then the next n lines specify the prizes. Each of these lines starts with integer k, which is the number of sticker types required for the prize, and then followed by the types required. Final integer in each line is the positive cash value of the price. This is at most 1 million. Last line of each case gives m non-negative integers, which are the number of stickers of each type you have collected. There are no more than 100 stickers of each type. The most important thing in this question, which otherwise makes it really hard, is this line. No two prices will require the same type of stickers. Okay, so if you have a certain type of stickers, you know if it can be used at all, only one price will be able to use it. If two prices can use the same type of stickers, then you have to start thinking, okay, if I have 10 of those stickers, do I use 4 for this prize and 5 for the other one, or what? Because there are no two prizes that require the same type of stickers. If you have 10 stickers and if there's a prize that requires it, then all you do is just put all those 10 stickers to the prize. Okay, maybe later on we can talk about what happens in the later weeks. What would happen if this sentence is not there? But the fact that this sentence is there makes the problem a lot easier. And what you have to do basically is you basically look at each prize that you can claim, and you look at how many stickers you have for each type, and you take the smallest of them, right? So if you need one sticker 2 and one sticker 5, right? So you see 7 sticker 1 and 10 sticker 2, 5, then you can only claim 7 prizes. It's the minimum of all the stickers that you need from those types. So that's what we're going to do. Wait, let me see. So they're at most, each one is at most 1 million. They're at most and different prices. Okay. And there are no more than 100 stickers of each type. So you can at most claim a prize 100 times. Okay, so that means you can have at most 100 million for each prize, and at most 10 prizes or at most 1 billion that you can claim. So why is that important? Because if it is more than 2 billion or so, that's more than a 32-bit integer normally. So you'll need to use something bigger. If you just use int, it could overflow. But because the total is at most 1 billion, you can just use normal int. Okay, so what is it called? Fast food. Okay, so the first number is the number of cases. I just got T. So this is a quick way to do something T times. So everything is going to be in soft. Okay, so what are the things that so first is N and M, number of prizes, the number of different types of stickers. And then for each prize, you will have a certain number of, okay, so for int I equals to 0, I less than n, I plus plus, now I need to have the sticker type. So what I'm going to do is I'm going to have a vector of prize, and there will be n prizes, and the vector will then store vector of that each prize would store the stickers that you need. So types are labeled 1 through m. Okay, so int k, c in k, that's the number of stickers. And then for int j equal to 0, j less than k, j plus plus, I'm going to read in the type, right? So in type, c in type, and then price I dot pushback type. Now the types are labeled 1 through m, but in C++, we usually start indexing 0. So I'm actually going to do -1. So the types are actually 0 to m minus 1 in my program. Okay. And then at the end, I have the m integers, which stores the number of stickers for each type. So vector int stickers for m of them. And that reads all of them. And then I need the total of all of the prizes. So I basically just go for each. Oh, wait, I forgot something. So the prizes were n because I forgot about this. Next n line specify how much it is. So I need to. So where is this? It's 3123. Okay, the actual price. I forgot to write that. So so what should I do? Okay, so now I've written the amount. So for each one, what am I going to? I'm going to look at the number of stickers, the minimum number of stickers for all of these types. So basically what I'm going to do is I'm going to look at price I. So how many prizes I can have. And I'm going to initialize to the basically this maximum integer, because what I'm going to do is I'm going to keep on making it smaller by picking the minimum of this number with the number of stickers I have for each type. So when you try to keep a running minimum, you initialize to sort of the biggest possible number. So for auto t, so this will loop through all the types of price I, num prices equals to minimum of the current running minimum and the number of sticker, that should be square bracket, the number of stickers for this type. And after that, that would be the minimum of all the stickers that you require. So total is number of prices times the amount of that price. That should be what I need. Okay, I'm not going to just submit it without checking. So let me just try it and make sure it works before I submit. Okay, so I did something horribly wrong. What did I do? So amount is a vector. Oh, yeah, because this was a vector of int, and I just put it here, whereas amount should be just a single vector of int. Okay, that's better. Okay, 500, 2500, and 1900. 500, okay, that looks right. So let's give it a submission. Okay, so that's good. In case you didn't know this metadata, this was actually a problem from the Rocky Mountain Regional Contest 2013. It's in fact, it doesn't say, but it's actually one of my problems. So it'd be pretty embarrassing if I couldn't solve my own problem. Anyway, okay, this one is very short description anyway. Write a program that computes the difference between two non-negative integers. That seems pretty easy, yeah? Take two numbers, subtract, but make sure that you take only the difference, so you don't say -2, right? And here and there. Each line has a pair of numbers between 0 and 10 to 15. So this is the part where it's kind of tricky, I guess. Why is it tricky? Because a normal integer goes up to about 2.147 billion. So that's about 10 to the 9, 2 times 10 to the 9. And this is too big. So if you just use an integer, it's not going to work. And what you have to do is to use a 64-bit integer, which is long enough for this. And so this is, I guess, an exercise to make sure that you know how to use 64-bit integers. There are two ways you can, well, there are two main ways you can use 64-bit integers. You can either call them long, like this, or you can call them int64t like this. So int64t is more standard, so it's preferred, so I will do that. But the other way also works. So basically what you have, right? You have two numbers, and you want to keep reading them as long as there are two more numbers. So this will read two numbers as long as there are two numbers, and you can and it'll quit when you get to the end of the file. So you can say, well, you can do many things. This is probably the easiest way, using the absolute value function. The absolute value function for integers it's overloaded in C++, so it will automatically choose the right one depending on what data type you use. And I think that's it. I'm not even going to bother compiling checking. Uh-oh, what? Oh, submission site. Okay, so I mean, this is probably like, this problem is so standard that probably other people are submitting code that just looks just like this. And this is kind of like a, I don't know, plagiarism warning, I guess. Let's see what it says. Somebody else also submitted something like that, but for a problem so similar, that's really not a surprise. Okay, so last one, Babofish. So you have these dictionary word entries up to 100,000. Basically, the entries look like this, right? Word one, word two. And then what you're supposed to do in the second list is to look up the first dictionary, see if there are any matching um, word in the second column, and if so, spit out the one in the first column. And if you don't know, if you can't find anything, then you're supposed to say A. Okay, so basically, if you have learned the C++ map, or if you're in any other language, you can have something similar. That's what you need. There are other ways you can approach this, of course, but map is the easiest. The difficult part, if there's any part that's difficult, is to figure out how you read the input. The problem is you need to have a way to decide when the first part of the input is finished and when the second part starts, right? And so you know that it starts at this blank line. So you can't just say read two words and just keep reading two words, because otherwise you will not know when the blank line is. So the only way you can deal with this is to read it one line at a time. Well, get line, and then if it's not blank, I keep going. So this part is to read the dictionary, and as soon as you see a blank line, you're done the dictionary. So now that we have this line, how do we break it apart into two strings? The easiest way is to turn it into a string stream, And if you don't know what that is, it basically means take the content of a string and pretend that it's kind of like a cin that you can read from. Pretend that somebody's actually typing the content of the string on the keyboard. So you can say, I don't know, S1 and S2, and then I can say IS, and that will read in the two strings and separate into S1 and S2. And now I need to put it into a map. So string, call it dictionary. And I would say dictionary S2, it's equals S1 because S2 is the key that you search and S1 is what you want. And it, of course, tells you, what does it tell you? That no foreign word appears more than once in the dictionary, meaning that you don't have two words that are the same on the second column. So otherwise you can't use a map, because then if you cannot guarantee that S2 is unique, you cannot use a map. Okay, so now we look for the translation. So wow, cin word, and then we just ask if we find it in the dictionary. So this, it's a way in C++ to ask, find the word in the map, and it will return an iterator to that entry. But if it's not found, it will return dix.end. This is a universal thing in C++ containers. You try to look for something, it's not there, it will return an iterator to the end of the container. So if it's not the end, that means you found it. So what do? You see out the entry associated with that key. Otherwise, you print this A. Okay, so of course you can use other data structures, but remember that there are up to 100,000 words, and you might have to do this lookup 100,000 times. So if you just do a linear search every time, that's going to be too slow. You could, if you want, organize your own sorted array and then use binary search, but it is way easier to use a map. Okay, that's it. Okay, so that's all for this week. Please feel free to look at these things, and feel free to ask me and reach out if you want any comments. Even if you've done it and you want to know what I think about your solution, feel free to reach out. Otherwise, I'll talk to you guys again next week after I post the next problem set.